This is one more video in which we're dealing with multivariable equations, in which maybe we don't know what they equal, but that doesn't mean we can't re-express them or isolate things that we want to solve for. Okay, so we're going to start with looking at what we have here. It says if z, so some number z is equal to another number x minus another number y, and w is some number that's equal to y minus z, we've seen these numbers before, all over z. Okay, we want to express w in terms of x alone when y equals 5. So this is kind of like the last problem I did when we related the perimeter and area to a rectangle, but you notice that we have two equations here. And what they're asking us to do is rewrite this, express w. So in other words, get w by itself, which is nice, by the way, because it's by itself here. But we want it in terms of x alone. We don't want to have any y's. We don't want to have any z's. We want to know what is w equal with respect to x. So what I want to point out here is this. They both have some variables in common, so we're going to be able to relate them to one another. So even though y and z are over here, and I want to rewrite them in terms of x, we know how y and z are related to x. Okay, so we can actually do some simple substitutions to work this out. Furthermore, we were actually even told that y equals 5. So right off the bat, if they're saying, hey, I want you to rewrite w in terms of x alone, well, let's do this. Wherever we see a y in either of these expressions, let's take it out and let's substitute in or plug and chug with the value that we see. Okay, so we say this is 5 here. So we know that w equals 5 minus z over z, which is not all x's, but we did get rid of a y. Furthermore, if we head over here, we say, well, z is equal to x minus y, where we certainly know that y was given to us in this instance as being a value of 5. So z equals x minus 5. Okay, so the nice thing about this I want us to see is this. Well, we wanted to know what w was, or is, in terms of all x's, but I don't know what z's are with respect to x, but I know how z is related to x. I know that z equals x minus 5. Let me write this a little bit cleaner here. Z equals the number x minus 5. So what this means is everywhere I see a z over here, like right here and right here, I can go back and I can actually run some substitutions. That is, put in blank sets of parentheses and substitute in what I know these things equal, which in this instance, it happens to equal the quantities x minus 5 and x minus 5. So simplifying the top, let's talk about a few things here. This one's really important. You'll notice that you have a negative in front of an entire parenthetical quantity. What that does is actually makes this 5 minus x plus 5, and let me tell you why. The reason why is because this is construed as being a negative 1 out front, okay? And so when you have a negative 1 like this, I suppose we could write this as add a negative 1 times this, add the opposite, but we have to distribute this negative 1. So I got 5 plus, now negative 1 times x is negative x, so 5 plus a negative x is 5 minus x. And then 5 plus negative 1 times negative 5, which is positive 5. So on the top we get this, and in the basement we get x minus 5. Furthermore, I know that 5 and 5 here, those are like terms. So I'm going to put my x out front. I get negative x plus 10 total constants all over x minus 5. Okay. So this right here, let's keep in mind that when we started, this is w. Okay, so what we wanted to do in the first place was express w in terms of x alone when y equals 5. So after plugging in our 5 and doing some substitutions, we could say, well, then it is true, if all of our predicates up here were true, that the width, or I don't want to say width, the w variable is equal to negative x plus 10 over x minus 5. And also we could put quantities around this to represent the fact that they're just a number divided by a number. But another example of how to work with a multivariable equation and do some substitutions.